Welcome to another video on exponential growth. This one has to do with doubling time. So if something is growing exponentially, there's some fairly quick ways of finding out how much time it will take for a population or even an investment or something to double in size. So this gives us a population of, Tacoma's population in 2000 was about 194,000. It says it's been growing by about 11% each year. That's not actually a fact. But if the growth rate stays the same, estimate how long it will take Tacoma's population to double using the rule of 72. So the rule of 72 it helps us find doubling time, and I'm just going to use this little formula. Double time I'm going to call dt. The double time is equal to 72, as you can see, over R, capital R. Now, capital R is the growth rate in its percent form. So if we say capital R percent is equal to 11%, then capital R is the 11. Typically, we write little r as the decimal version of that. So we usually write it that way. But for this rule of 72, this very quick and relatively accurate estimate for double time is 72 over 11. So if you take 72 and divide it by 11, that ends up being 6.545454. So it's 6.54 repeating. Now this says rounded there is tenth of a year, so I'm going to say that's about 6.5 years. So 6.5 years it would double if indeed it were growing at 11% each year, which it is not now. Now that's obviously super easy. I mean, just take any interest rate, divide it into 72, and you will get the estimated time it will take to double. Now, a more accurate way to do that is if the growth rate stays the same, it says estimate how long it will take Tacoma's population to double. Same question, but this says set up the population growth model P sub n is equal to P sub 0, the initial population, b to the n power, where b is 1 plus r. And so we know in this case r is 0.11. So our b in this case is going to be 1 plus 0.11 or 1.11. So our formula is P sub n is equal to P sub 0, that is the 194,000, and I'm just going to put a little k down there for 1,000. 194,000 times 1.11 to the n power. Now for that to double, this P sub n has to be 194,000 doubled. That happens to be 388, so that's 388,000. And you're going to see here we're going to get a little shortcut for this even after we're done with this problem. Is 1.11 to the n power. Now to solve that, we're going to divide both sides by 194,000. This by 194,000. And you're going to see that it didn't matter what that initial population is. I got the 388 by doubling 194. So this is always going to give you a 2 no matter what the initial population is. So every single time you ask for doubling, then you're going to get a 2 there times b to the n power. Now the solution to this, if we use logarithms, there's different methods of using logarithms, and kind of a more traditional method of using logarithms is to take logs of both sides. But the definition of a logarithm says that if this is the base of the power, then the log of base 1.11 of 2, this number, is equal to the exponent n. The exponent is always going to be equal to the log with this base of this number. So, and that is the log of 2 over the log of 1.11. That's the change of base formula we know. So look at what we could have done. We could have taken the log of 2, if that's our double, if we're doubling it, over the log of what? Of b. That's what's equal to n. And we just need to know that b is equal to 1 plus r, right? b is 1 plus r. Or you could say the log of 2 over the log of 1 plus little r, the decimal version of that. So to do that on our calculator, we will bring up our TI-30, and here's the log key is right up here, log, log of 2, and then we have to put a closed parenthesis because it prompted it, divided by the log of 1.11, put a closed parenthesis in there, and there's the log of 2 over log of 1.11, and we hit enter, and look at that, 6.64. So to the nearest tenth of a year, that would be 6.6. Well, 6.6, remember what we got for the other one was 6.5. So it's a little more work to do this, but if we think about this, this is our double time. This was our double time formula using logs. So we have this double time formula using the rule of 72, and this double time formula, which is a little more accurate, using log of 2 over the log of, and we'll just put 1 plus little r. You know how big R and little r. Big R doesn't change to a decimal version, little r does. So there's the two formulas we could use for this. That formula for doubling and this formula for doubling. Either one. It depends on what you're being asked. Okay, I hope you found this video helpful.